Hi, I'm Wayne Leck and I'm doing question 4 of June 2013 AQA Core 3. So according to the examiner's reports, a high proportion of students gained full marks. However, because it's quite a big question, there's a lot of areas where you could trip up, and indeed quite a few students made arithmetic mistakes or other silly mistakes that I'll talk about during the question. So if we turn to the whiteboard, let's go through question 4. Okay, so question 4, by forming and solving a quadratic equation, solve 8 sec x equals 8 sec x minus 2 sec squared x equals 10 squared x minus 2 in the interval where x is between 0 and 2 pi, giving x in radians 3 significant figures. So it's going to boil down to the sort of thing we had in Core 2 maths, when you have something like sine x equals 0.2. You do sine to the minus 1 of 0.2 to get x. It's going to be something like that. It may well not be sine. More likely it's going to be cos, but we'll get to that when we get to that. This is the first part, and it actually tells you to make a quadratic equation. So this is the new Core 3 bit, the really tricky bit. Now we have a sec squared and a tan squared. The question is, do we get the sec in terms of tan, or the tan in terms of sec, or do we get them all in terms of cos or sine? That can be a bit of an awkward question. I have 2 sec things and only 1 tan thing. So I'm going to convert the tan squared into sec. That would make it easier than converting both of those into something about tan. And I'm going to use the relationship tan squared x equals sec squared x minus 1. So that's a relationship you should know. So when I'm going to put that in there. So what I'm going to end up with is this 8 sec x, because the left hand side isn't going to change at first. 8 sec x minus 2 sec squared x equals, so now I've replaced this tan squared x with this sec squared minus 1, and you've got minus 1 and minus 2, so it's going to equal minus 3, so we get sec squared x minus 3 on that side. So I'm going to take the sec squared x over this side. Well, no, I think more sense would be to take this minus 2 sec squared over that side. So we want a positive amount of sec squared, because then it's easy to deal with. So when you take the 8 sec squared and the minus 2 sec squared over to that side and equate it to 0, we get 3 sec squared x minus 8 sec x minus 3 equals 0. At this point I would advise you factorise it, and sometimes it may well not factorise and you'd have to use the quadratic formula. First, I think, yeah, this one factorises. 3 sec x is going to be in one bracket and sec x in the other. That part's obvious. And then you can either have plus 1 and minus 3, or minus 3 and plus 1. I make it to be plus 1 minus 3. Because that makes minus 9 sec x. Yeah, that's right. So then we're going to get 2 values of sec x, which is what we know how to do this sort of thing from Core 1 and Core 2. So we get sec x equals minus 1/3, and sec x equals 3. Okay, so what is sec? Well, it's 1 over cos. So we get 1 over cos x equals minus 1/3, because you can't do sec to the minus 1 of these things. And 1 over cos x equals 3. Therefore cos x equals 1 over 1/3, which is minus 3, and cos x equals 1/3. Now we can do cos to the minus 1, but you hopefully have noticed, if not I'm going to point it out because I've noticed, this cos x equals minus 3. You can't have cos to the minus 1 of minus 3, that wouldn't exist. And I would mention that in your exam, you say that can't happen. Alternatively, you could have gone up here and said sec x equals minus 1/3 doesn't exist, if you could notice that. If you know what the sec x graph looks like, you'd know that it can't equal minus 1/3. But I think it's easy to spot down here. If you do cos to the minus 1 of minus 3, you'll get a math error. So that that's a no-no, big cross. So all we've really got is this cos to the -1 of a third, so the other one, and that actually gives, I've actually done it already to make it quicker, it has to be in radians, so make sure you calculate it in radians, and to 3 significant figures is 1.23, and then we use the symmetry of the curve. So I'm going to rub out some previous stuff to sort of explain this bit. So I'm going to rub out this, hopefully you're okay with this, if not you can just go back in the video. I'm going to rub out a little bit of this stuff and think about what we've got for the symmetry, because this is the part that is actually more common to trip up on as this last bit. So we're dealing with a cos graph between 0 and 2 pi. It looks just like this, where that's 2 pi. And this is pi. Now 1.23 is about here, and to check that we know that this value is half pi and 1.23 is less than half pi, so it's going to be somewhere along this line going across. So by symmetry there's going to be another value here, so we can find the distance between that and that, which is just 1.23, and minus that from 2 pi, and that will give you 5.05 to 3 significant figures. Alternatively, at this point you could have found the distance between there and pi and added that on, it would be the same. Either way, we're using the symmetry of the curve to find the last point, and you realise those are the only 2 points. They're in radians. Common mistake in this is to either not be able to do the symmetry right, or to put them in degrees, or not to do them to 3 significant figures and instead do them to 3 decimal places. Now it's surprising with a question sort of as tricky to get your head around as this, that the things that people actually trip up on is the simple little final points. So I thought it was worth pointing out. Altogether in this question there are 7 marks available. It's just one question, one part. Hopefully this helped. Let's get on to question 5.